Here's a question that sounds simple until you actually think about it. When you turn a corner, your outside wheel travels further than your inside wheel, sometimes by half a meter. But both wheels are bolted to the same engine. So why don't they fight each other and shred your tires? The answer is a lump of gears under your car most people have never seen work. Stick with me, and by the end, you'll understand exactly how it solves this, and why it can also leave you stuck in the mud. Cost and feel mostly. An open diff is cheap, light, smooth, and needs almost nothing from the driver. Perfect for the everyday car that spends its life on grippy roads. Limited slips cost more, wear their clutches, and can tug at the steering under hard power. So car makers give performance cars, off-roaders and tow vehicles the clever diff and leave the shopping car with the simple one, increasingly propped up by traction control that just brakes the spinning wheel to fake the same effect. But under every single one of them sits that same little cage of spider gears, quietly solving a problem you never even knew your car had. The fix is the limited slip differential. The idea is to allow some speed difference for cornering, but resist a big one when a wheel loses grip. The common design packs clutch plates between the side gears and the cage. Under load, ramps force those plates together, and the friction lets the diff transfer more torque to the wheel that still has grip, often biasing 60 or 70% to one side. Torsen designs do it purely with worm gears and clever meshing, no clutches at all. Either way, you keep the smooth cornering of an open diff but claw back the traction when you need it. So why doesn't every car just use one? Picture one wheel on ice and one on dry tarmac. The icy wheel has almost no grip. Since the diff must give both wheels equal torque, the moment the icy wheel spins freely, the torque it can transmit collapses to nearly nothing, and the tarmac wheel gets that same near nothing. So you sit there, one wheel spinning uselessly, the other dead still, going absolutely nowhere. It feels like the car's broken. It isn't. It's the differential doing exactly what it was designed to do, being fair to both wheels, even when fairness is the last thing you want. Engineers call this an open differential, and it's why the clever fix exists. Now, a subtlety most people miss. A differential doesn't just split speed, it splits torque, and it splits it equally. Because the spider gears act like a balance beam, they can only ever push both side gears with the same force. Whatever twisting force the slower wheel gets, the faster wheel gets the identical amount on a good road that's perfect and fair. But this is also the differential's fatal flaw, because if both wheels must always receive equal torque, then the wheel with the least grip sets the limit for both, and the wheel with the least grip sets the limit for both, and that leads to the failure everyone's seen but few understand. Here's where it gets clever. Go into a corner and the inner wheel slows down. Because the side gears are meshed with the spider gears, the moment one side gear slows, the spider gears begin to spin on their own cross shaft. And here's the beautiful symmetry. As they rotate, they wind speed off the slow side and add exactly that much to the fast side. If the inner wheel drops 10%, the outer wheel gains 10%. The outer wheel gains 10%. The average always equals the input, so both wheels stay driven, both keep receiving torque, yet each is completely free to turn at its own speed. No skidding, no fighting. That genuinely is the elegant trick. Inside that spinning cage sit the spider gears, usually two small pinion gears mounted on a cross shaft, meshing with two side gears, one on the end of each axle. This is the heart of the whole thing. When you drive dead straight, both wheels resist equally, so the spider gears don't rotate on their own axis at all. They just get carried around by the cage, locked in place, driving both axles at identical speed. The spiders are along for the ride, but watch what happens the instant one wheel wants to spin faster than the other, because that's when these little gears wake up and start doing something rather beautiful. The differential's whole job is this. Take one spinning input from the engine and split it into two outputs that can turn at different speeds, while still driving both. Power arrives down the prop shaft and hits a small pinion gear. That pinion drives a big ring gear, sometimes called the crown wheel. That's your first job done. Turning the drive 90 degrees to reach the axles and gearing it down, often around 3 or 4 to 1. But here's the clever part, the ring gear doesn't connect straight to the axles. Bolted to it is a cage that carries a little cluster of gears, and those gears are where all the magic happens. Let's start with why this is even a problem. Drive in a perfectly straight line and both driven wheels roll at the exact same speed. Easy. But the moment you turn, the geometry changes. The outer wheel is on a bigger radius, so it has further to travel in the same amount of time, which means it has to spin faster. On a tight turn, the difference can be 20 or 30%. Now here's the crunch. If a single solid axle drove both wheels equally, one wheel would have to skid the whole way round. That's tire chirping, driveline stressing chaos. So how do you send power to both, but let them disagree? Quick word from what keeps the lights on here, and this one's for the people watching who actually work on the tools. If you're a builder, contractor or running a site team in the UK, you'll know the pain of writing RAMs, risk assessments and method statements. This video is sponsored by RAMs Ready, which lets you generate proper compliant RAMs in minutes instead of losing an evening to